Good day to you, my dear friends. Well, it's time to solve some LeetCode problems. Yay! Where? I can't speak. Well, first of all, as you know, I started to go through that section, Arrays 101. So let's start with the problem from this set. So yesterday we discussed duplicate zeros, now it's time to merge sorted array. But we're gonna do this problem not here in this ugly interface, but here, where it's much more nice. Well, what do we have to do? We have two arrays, nums1, nums2, the length of nums1, and the length of nums2, and we want to create a new array to merge these two into one big array with the lengths m plus n, and all the elements should be sorted. Again, it's very similar to the problem from yesterday where we added zeros, right? So originally I solved this problem with let me see, just by inserting elements and popping extra elements, and that is a very bad approach. What is it? Yeah, you see, inserting, then popping. Why it's bad? Well, because when you insert something into an array, you have to move all the elements that go after this one, and that's a problem. But luckily we have another solution, and it's very similar to what we discussed yesterday with this problem, where we have two, let's call them pointers, I and j, but in this case we're gonna have three. Well, what do we have? This array, 1, 2, 3, and 3 zeros, and 2, 5, 6. 2, 5, 6. So we want our first pointer, to point here. Let's call it I1, for example. And we want our second pointer to point here. Let's call it I2. And we want to have, let's say, j pointer that's going to point here. Or not? No, not at all. How can we select something here? Can we? Well, this is bullshit. We want it here, of course. And I2, we want it here. Because we want to move backwards, and we want to find the biggest number first, and then proceed to smaller numbers. Now let's do this part. So we have these pointers. Let's say I1 it's gonna be equal m minus 1, and I2 it's gonna be equal n minus 1, and j is gonna be m plus n and minus 1. Now what do we want to do? Now there are many different solutions how we want to iterate. Let's do something like this: m plus n times do. So what we want to do? We want to check if, let's say, I2 let's do like this. Of course it's not I1, it's nums. Oh, I can't think today. So we want to take I1th element from nums1, this one, and we want to compare it with I2th element from nums2 with this one, and if this element is bigger than that element, we're gonna put this element here, otherwise this one. Let's try. So we have this if, but it's definitely not our case, because in our case this one is smaller. So nums j is gonna be equal to this one. And of course we want to decrease our j by 1 because we want to move. We want to move it to this position. Also, we already checked this element, we put it here. We also want to move I2 okay, and then we check again. We check if 3 is bigger than 5. Well, no. So we again, let me close it. We again go here. But what about this condition? Well, of course it's gonna be nums j equals to this. And we want to decrease it. And it's almost gonna work, I think. But at some point this I1 can become less than 0 and we're gonna have a problem here. So we also want to check if I1 is bigger or equal to 0. Let's check. Because it's not nums, it's nums1. Here it's also nums1. still we have a comparison with nil. Where do we have nil? Let's think. Well, yeah. Also want to do this check. It's better. Oh yeah. So it's is it -1? No. Why is this happening? Well, because because of course it shouldn't happen. I remember this problem, and I remember I solved it without any difficulty. So I just can't think today. Why? And if we remove this condition, it's gonna be even worse. It's gonna be the same. Problem is we have 6 here again. Hmm. Nope. See, this becomes -1 at some point, and if it's -1, then we fail this check and go here and we put 6 in this position. Okay, let's do like this. Oh, it's not no, it can't be no. No, we want to check if I2 then we're good to go, right? Oh, much better. Can't believe we stuck. Now, of course, it can be done with a while loop. Or with like 3 while loops. But if I know that we're gonna do this n plus n number of times, then well, let's just do it this way. Well, this was a problem number 88, merged sorted array. Now for something completely different. Let's go and list all the problems. We were going through the first page of easy problems sorted by acceptance, and we discussed like half of these problems, but then I encountered where is it? Okay, all this is done. Let's open this one. We're gonna need it. It's called execute cancelable function with delay. Where is it? Ah, thank you. This one. Well, if you remember, it wasn't solved like yesterday. And it's not a very hard problem, but I just couldn't understand. What do they want from me? Look, I attempted everything. I think I tried to solve this problem for a week until I finally succeeded. So, succeeded? Is this a word? Yes, it's a word. So, we have a function, an array of arguments. So, this is a function. These are the arguments, and we have time in milliseconds. And we want to create a new function, and then we want to cancel its execution. For example, here we have time 20, and here in the cancellation we have time 50. So this function fires before we cancel it. Here we have a time 100. No, calm down, Chris. Hello. Nice to see you as always. This one was so hard, and I spent like a week on this one. And it's not even hard, it's just tricky. You do not encounter similar things too often in real life, so they are very nice. And this one, we have a time of 100, and we cancel this function after just 50 milliseconds, so it doesn't fire. And I didn't understand it, I just couldn't. And let's go back to this previous problem where we have to call function only once. You know, we call it once, and then when we call it the second time it doesn't work. The problem is they look similar, these two problems, and we also have to use closure here, but we do not call it a second time, we just call it once. When we set timeout, we call this function, and this just destroyed me. I couldn't understand anything until I invented the most absurd thing in the existence. It's a little shameful for me even to tell you this story, but when did it ever stop me, you know? So I used this, and I recorded, let's call it timeout in prototype, or how do we call it in constructor. It was awful. So here I'm gonna do set timeout, and in this timeout we're gonna return function, we're gonna do this in t milliseconds. And then what do we want to return? Well, we want to return a function, of course, because we're creating a closure. And in this function we want to take this timeout, and we want to clear it. And this is what I invented in a week. But that's such a strange solution. I mean, look, when we create this cancel function from cancelable, we do this, but why do we want to put it in the prototype or in constructor? I don't even remember. If we can just create a variable for it or a constant for it, const timeout, and use it, that's a mystery for me. It's almost the same thing, but I just couldn't invent it. And why does it work? Well, because when we create this cancel function, we launch this timeout, and when we call cancel function, we clear this timeout. It's very easy, but it was very hard to understand this problem and invent some kind of a solution. I tried everything. Yeah, but there is an even better solution, in editorial solution, believe it or not. Yes, because in JavaScript section they're really good, as no condom Chris already said. We can return this only if, let's say, we need a new constant for that, not constant, let it's called is cancelled, a boolean, and it's not cancelled yet. And we're gonna do this only if it is not cancelled. Too many brackets. Like this. And of course it's gonna work, right? And here we just wanna do this small change. Cancelled equals true, and that's it. So when we reach this time limit, is cancelled is gonna be already set to true in this second scenario if we call this function. Before that it is false, and we do not run this block until we hit the time limit, so we only check the value of is cancelled when we are here. It's beautiful, such a nice solution. And this small problem took me a week. Yeah. But I was such a happy man yesterday when I solved it on my own. Not in optimal way, but still. Now let's go for another problem that I tried to solve for 4 days now. It's our favorite problem about a rectangle. I think I'm gonna solve it today. Yes, it's a Lipton tea. They sell it all over the world. Well, not today. Enough with JavaScript for today. Unless you want to spend like a whole week with me while I try to solve another JavaScript problem. So, where is my favorite rectangle problem? So yesterday we managed to beat a few of the test cases, but still it's not enough, and I think I know why. Let's hit a bad test case. I think we sort too much. I need to remove all of my sortings. See, here is a test case number 107. Look, my original assumption was, because we look for a smallest area rectangle, that it's gonna be really small. So I sort everything and start from the smallest. The smallest difference between x coordinates, the smallest difference between y coordinate, but nothing can be further from the truth. It may be the biggest square in the universe, and it's gonna be the smallest one if it is the only rectangle, you know? So I do all this sorting, and still after that I need to iterate through everything, because it can be very big rectangle. So I think we're gonna pass this if we just remove the sorting. You see, we sort pairs here, by the difference between their x coordinates. Why? Oh lord. Let's not do that. And maybe we already gonna pass at least this test case. We need to take it to add it to our test cases. It's the next one. Nice. We are one step further. And I think another problem is another sorting that I do. Because I sort these keys, I do not need to do that. Let's also get rid of this logic and just use keys everywhere. So instead of sorted keys, we just want to use hash keys everywhere. Let's not make a mistake here in all this renaming. Wait, let's not do it like this. Not like this. Let's still put it in some kind of a variable. I know, keys. And it's gonna be better. Much better. Where we have sorted keys here. It's the same logic. We do not know where we have this rectangle. Maybe in the very end. Maybe we do not have it at all. Then why do we sort? It was a terrible idea. Luckily, I realized that. I think like this. Maybe everything will break. Maybe not. We'll see. It's the first two. Again, it was a test case number 108. It's even worse now. That's interesting. Well, yes, if they're sorted, then we do not have this rule anymore. Then the next one is always bigger than the previous one, so we can have a negative area. Where do we let's make it module absolute, and also give x. Take it. Let's call it apps div x. Let's hope. 104. What's wrong with this one? Something is wrong. Maybe we do not want to break anymore. Not sure. Let's try to comment it out. Let's use this test case. Without a break, yeah, this is not the problem. Oh, I know. I know what is the problem. The problem is this check, where we check while offset is less than equal than length. It doesn't make sense anymore because we do not have everything sorted. Well, no. Not this one. This one. We can have an offset bigger than mean area because they are not sorted anymore. So even with a huge offset, we can actually have rows that are very close to each other, and it was impossible back in the day, so we do not need this condition anymore. So this is our only condition, I guess. Yeah, it's green. 108, remember this number, it's where we failed. 107. What's wrong with you again? We still sort things here, by the way. Maybe we can just sort everything in the beginning. But why doesn't this one work anymore? Yeah, because of this probably. I had to take this test case. Yeah, 108 again. This is our favorite. Let's check this one out. Why does it fail? Can we say anything about it? Maybe because we do this intersect too often. I don't know. Well, we had some progress. Oh, that's for sure. It would be interesting to remove everything and use this test case to try to find the bottleneck where we have a problem. But it would be hard because it's a huge loop. Maybe we just want to try it again and we're gonna be more lucky this time around. Nope. It's funny that I'm solving exactly the same problem that I tried during your previous raid. Hello and thank you very much. Well, I had some progress since then, of course. I'm so close, but not close enough. Can do this, but probably again not today. It's like 4 days already. And we need to find where do we have this problem. Maybe because of this sorting. They built such a huge test cases and you do not understand what is the edge case here. What do they trying to check? So much is going on. And what is the right answer for this one, by the way? Oh, we do not know what is the right answer. Eh. Well, yes, the problem is I do not have any other approach yet. But who knows, maybe one more sleepless night and I'll have it. Without sorting, we need the same approach as here. We need an offset if we do not have sorting anymore. And it's gonna be much better because we sort a lot. And we do not save the results of our sorting, never. We just do this again and again and again when we use some coordinate. Maybe if we did it and after that we created a new hash, and in this hash we stored the sorted values, and if we want to use these values again on some other loop, first of all we're gonna check in this hash of sorted values, and if we do not have anything there, then we go to our original hash, take coordinates, sort them, you know. Because in the beginning, like earlier today, I had so many sortings. Like I sorted here and I sorted somewhere here and then again, and I managed to remove all these sortings except for this one. And this can be bad too if we have a lot of different x coordinates with the same y coordinate. You see, we have this x coordinate and it repeats like a lot. Not everywhere, but a lot. And we have this second one that repeats a lot. To the end? Yeah, to the end. So maybe this sorting breaks everything, I don't know. Definitely we have a huge row. Even this intersect is not that good if we have such a huge rows. And I'm almost sure that this intersection is a very expensive operation. That's for sure. We have just that's x, that's y. So at the same x we have a lot of rows. It's not that we have a lot of long rows, it's that we have a very long columns. Okay, so what is the problem? problem is that we have too many points. Fuck's sake, that's the problem. And y coordinates, they are very different. See? Let's just return keys. Let's look at them. How many keys do we have? It's complicated. Look at this. Where do we have a acceptance rate like 53? It's definitely not an easy problem. See how many rows we have here. That's why I wanted to sort them and start. Well, sorting doesn't help. Sorting doesn't help. I definitely should, well, take breaks. I'll just continue tomorrow again and solve something else. And I hope other problems would give me some insight into this one. By the way, maybe you have an idea what is a good problem to solve before this one. Maybe an easier version or something. But it's so close. Let's solve something else for now, because I want to solve at least one problem today. If not this one, then something else. Huh? No, we are here again. We are cursed with this problem. The one with horizontal space. See, in this problem, where is it? I also start with the minimum, but it doesn't help me, because who said that our rectangle is in the minimum coordinates? Maybe it's in the biggest gap, but it has a very small difference between its y coordinates. It's almost like a huge line, or maybe it's a huge column, but very small in x coordinate, in x dimension. So it's not that simple. But let me solve something. Maybe even something medium, but I do not want to encounter another problem like this. Let's solve something very accepted. Maximum binary tree. LeetCode would be happy. I hate trees. So, whoa, look at this. You are given an integer array nums with no duplicates. A maximum binary tree can be built recursively from nums using the following algorithm. They give us an algorithm. Create a root node whose value is the maximum value in nums. Recursively build the left subtree. You have to rebuild the whole tree. thank you, LeetCoder. Good night to you. It's not gonna be simple. So we have nums. Okay. Look, this one. 3, 2, 1. And all the numbers are unique. Not enough examples. Here are the and 2 is smaller than 3, but we go to the right here. It's a right node. 0 is less than 5, but it's not right, it's left. Because it's to the left from the 5. So we have this 6. We want to take a maximum value. From here it's 3 and it's to the left of 6, so we put it here. Yeah, like a lightning before a thunder. Thunder is always here. Here we have a maximum, it's 5. Yes, but 0 is to the left of the 5. Let's build a hash. Or not. How big can be this array of nums? Well, not great, not terrible. I feel like I need something easier for today, but I also want to solve it. probably here instead of doing an intersection. I don't know. I can't think about two problems at once. Let's start from the beginning of our array. Just to get an understanding. So we have this first element. We don't know anything about it. We want just to create a node. Not node. How do we create a node? Tree node, new, and its value gonna be nums first, right? I don't even remember that. Oh, just like this. That's how we build a node, ladies and gentlemen. Then we check the next element. Nums. Just for now, let's call it second node. Now, second node, we want to check which one of them is bigger. Second node bigger. Nah, let's do this the old way. Of course, we're gonna solve it with what? With probably each iterator, or maybe even with recursion, I don't know. But for now, just for now, let's check. We're gonna need else, of course. So if second node is bigger than node, nah, it can't be like that. bad. Okay, let's do this another way. So we have this array. Let's find the maximum element, and it's gonna be 6th. And we want to find its index. Again, not good. With index. Kinda understand what we need to do here, but I don't understand the optimal way yet. Num and I. So we're gonna create a hash where we store all the indexes of every element, and we know that every element is unique. Also, let's use this opportunity to find a maximum element. So if num is bigger than max, then max equals num. So we have our maximum too. Right? Right. Now, you want to take max index is hash max. Right? Right. Now let's call it left array is gonna be what? It's gonna be what? Left array. What I do not want is iterate again and again and again. It's gonna be awful. What if we also have an array? It's not an array, how do we call it in programming? It's gonna be a stack. Let's call it a stack, and it's gonna have max here. But what if we do not have a 0? It's a possibility. Okay, so our stack is gonna be just nums sort. Again, not good. Okay, let's do this the dumb way. My favorite way. So have this nums. It's gonna be from 0 to max index, but not inclusive. Maybe we need round brackets, I'm not sure. Let's check what it's gonna give us. Left array 3 to 1, great. And we have a right array also, which is nums from max index plus 1 to the end. Rah. It's a right array. Yes. And now we want to create a node. It's a 3-node new. And as a value we're gonna use max. And as a node left, we're gonna use the same thing, and we're gonna give that thing left array. And node right is gonna be right array. And we do not want to recreate this hash every time, so let's make it a default thing like this. Otherwise we're gonna send it, right? And we're gonna return our node. Wait a second, it's a right here. I hate this. Oh, not this. Wait. We only need to do that if oh, that's bad. Definitely do not want to do that. I do not know if such a hash equals empty hash. And of course we want to return nil if no empty. Well, let's see what's gonna happen. I can't believe it's green, but we're gonna hit time limit. It's solved. Ugly, but we solved it. medium problem. You see, they're not all like that bloody rectangle. My ass is gonna be like a rectangle because I sit so long on this problem already. Well, where is a raid when you need one, when you are successful, when you are on your best, you know? No, no one's here when you are good. People always raid when you are at your lowest. And of course I'll think about better solutions for this problem tomorrow or day after tomorrow, because we have quite a big backlog, unfortunately. I solve faster than I can explain and research. Whew. But that's it for today. It for today. Maybe we do not need hash for that. Maybe you want to just find maximum and its index, and then nah. I don't know. Where is a lead coach when you need one? Yeah, it's time for me to go. Well, tomorrow we're gonna discuss some problems that we already solved in order to find the best solutions and approaches. Also, we're gonna solve something new, and of course, we're gonna attempt to solve our favorite rectangle problem. So goodbye and thank you very much, my imaginary viewers. Whoa, someone followed me today, by the way, and I have 25 followers of 25. Someone followed me and I didn't even thank him. Why do not they write to the chat? No, there were no notifications about followers. But unknown person, thank you very much. Or maybe I'll just open another window and I'm going to find who that was. Who was that? Bloody hell. Can you see that? I wonder. Wonder if you can see my screen right now. My little runaway. Run away. Oh, but we reached that goal yesterday because someone followed me yesterday when I wasn't streaming, and it was Alien Fun Bug. Well, thank you very much, Alien Fun Bug. I appreciate it a lot. Probably you will never return, but still, that was a powerful thing to do, to join my quest to solve all LeetCode problems. I'm going to shut up for now. It's time for me to go. See you tomorrow. Bye bye.